usually the second part of the back-to-back class is very, very tough. So almost exhausted. So, but I will try. And also, I had taught the operating system long time ago, and actually another professor was in charge of this class for a while. Then once he left, so I take over this class. So meanwhile, so it's a lot changes. So it's very hard to catch up, especially for the mobile device. Even though I'm using the couple of the mobile devices, but still hard to figure it out. So that's one of the reasons I changed my laptop to the Surface. So it takes a long time. So one day, the one tip, I figured it out. So please understand me too. But anyway, the basic, the algorithm and basic, the philosophy is not much changes. Still, we are using the von Neumann architecture in terms of the computer architecture, and we still use the Windows and Linux, and mostly even though the macOS is looks like the new one, but actually it's based on the Linux. So also the Unix can be considered the father of the Linux system. So basically two operating system. Okay, then we can understand. What about the mobile device, the Android, actually based on that. Even though they changed a lot of the algorithm for a specific task for specific, probably I don't find any traditional operating system textbook that include fully about the mobile operating system. Even though this textbook mentioned a little bit slightly about it, but the near future there might be the operating system textbook that can really explain. But anyway, it is true that a mobile operating system on top of the traditional operating system, such as Linux or the macOS and such like that. So it's not a big gap to learn the traditional operating system and algorithm. So last class we have talked about the disk scheduling algorithm. So disk scheduling, why do we need to schedule the disk scheduling algorithm? Is actually if you are using for example, SSD, solid state disk drive, do we need such a disk scheduling algorithm? That's actually we need, but it's very, very simple. We can use solid SSD does not need any physical movement at the disk on. So seek the latency and rotational latency. No, we do not have it based on the address-based the memory like the hard disk drive. So it doesn't need any such as seek time and rotational latency, which means you don't have to consider the complexity. Sure is the seek time first or the scan loop we don't have to use. Instead, only first come first serve. It's okay. Or if we need it, we can consider the priority base, like as if we use the priority based CPU scheduling algorithm. So in the mobile operating system, at the solid state, it will be much simpler. So mobile operating system is the same because we do not use such a magnetic-based, silicon-based hard disk drive. Instead, we are using such a solid state, the hard disk drive. So we are going to we learned about each disk scheduling algorithm. What do we consider as a cost at the time? Moving distance of the disk head. So in other words, we consider total the sum of the seek time latency. What about the rotational latency? Even though I mentioned that it is relatively small, also I realized that I forgot to mention that the rotational latency, to calculate the seek time latency, we can just sum up the moving distance. What about the rotate? You can consider the time. Also, you can calculate this is little bit harder than the seek time latency. So that is another reason, more complicated. So usually we consider the seek time latency, which is the sum of total moving distance of the head position. So we can first come first serve. this is in the queue we have the location of the data where you can read the data. That is the cylinder number. Okay, because we do not consider the rotational latency, which means we don't have to worry about each sector, only the cylinder position or track position. Track, the same position of the number of track is considered as a cylinder, so we can consider such a cylinder number 98. The next one is 183, and so on. In this case, we have the total 200 cylinder, which means the 0 to 199. The current position is 53, so we'd like to read the data from the 98 because it's the first term, so and 98, then the 183, no matter where it is located, we can just read in order of the arrival time in the queue. And then it will be like we visualize the moving trajectory of the header. It looks like that. Then we can just sum up to calculate the cost of the address list scheduling algorithm. Okay. Any question? Or is it? Some of that is 640. What about the shortest 6 times first? So somebody may be curious, why don't we read in the middle of that instead of the 193? That is the idea of the shortest 6 times. In other words, which cylinder is the nearest one from the current position. So from 53, we try to find the nearest one. But this one focuses on the local optima. So we do not consider the overall distribution of the data. So but anyway, it's reasonably the good performance. So show the 6 times first. Then we can sum up all the moving distance, but you can simplify the problem if you can understand such a thing to calculate the sum of them. Okay. Then scan is called the elevator algorithm. So sometimes you may be curious. So sometimes you are frustrated if elevator, you have 2 elevators. Sometimes it doesn't stop in my floor. Why don't somebody make the better algorithm? But the simplest way is just the elevator is going up and down from first floor to top floor. Okay, whenever their personnel or if somebody press the button, it can stop. So that is the scan algorithm. Okay, so it can move one way. Okay, it's currently moving for example, the higher cylinder number to the lower cylinder number, and it moved this way and read all the data, including the starting position cylinder. Because this is looks like the fixed, the static, the request, but there might be incoming. So also we don't know which one is the lowest position, whether you don't have to worry about just moving. It's an elevator. Okay. Once if there is any request, you can just moving forward and backward, forward and backward. That is the reason it touched the end. Don't forget, it touched the end, so you need to consider 0 and 199. Also another, so you can just sum up here to here and here to here. Okay. In case there is no incoming data request, we don't have to move. Okay, just waste of the resource. You can start here. But when you calculate the distance, don't make the mistake. It's 0 to 199 is 199. Many of the students just consider 200. Okay, so 199 minus 0. C-scan. This one is reading the data bi-directional. It moves down, up, and up. Why don't we consider only one way? It's called the C-scan. So it can move, for example, it's currently moved. So always the lower cylinder to higher cylinder number. So it's moving this way, read the data of the corresponding position. Then once it touches the end, 199, we do not have the 199, but that is always touch the 199 because we don't have to worry about which is the last one. Then going back to the starting position. Then reading the data and going back to the starting position. That is the C-scan. So one way. Okay. Then C-log is why don't we skip the starting point and end point? Just read the data the in between lowest to highest cylinder number. At that time, you need to consider which one is the minimum or which one is the maximum the cylinder number. So in this case, you can read the data and bring back to the lowest point and read the data and so on. Okay. Any question? I tried to explain in 5 minutes that I explained almost an hour last time. Okay, so that means you understand fully. I'd like to have another quiz. Nobody ask a question, which means you understand everything. The seat, please give me the leftover. Just to the right. Forget your name and ID. This is the most important part. You got it? You don't get 1, 2, 3, 4. You don't have to discuss. If you believe your friend, really, you can discuss. It doesn't touch. It's the same as the loop, but it doesn't touch. Anyone? Okay, so first, don't forget your name and ID. And the question is the same as the given example. So suppose that this drive has a 5,000 cylinder. If you want to, you can use a calculator. Okay, the number 0 to 4,999. The driver is currently serving request as cylinder. Current position is 2,150. Okay, you can start from there. And the previous request was the cylinder 1,805, which means it's moving lower to higher or high to lower? Lower to higher. That gives the direction of moving direction. Do you need to consider the moving distance between 1,805 to the 2,105? You don't have to. Okay? Then the queue of pending requests is first in, first out order. So which means the 2069 is the first one, then 1212 is the next one, followed by the order of them. Okay. Then using this information, why don't you calculate the cost by adding up all the moving distance? Okay. First come first serve. Choose the tick time first, the scan, and the loop algorithm. Please, quiet. You don't have to discuss.